Okay, in this video, what we're going to do is take a look at NURBS Surfaces. Now, we just wrapped up looking at NURBS Curves, and you're going to find it quite interesting that most everything you saw with NURBS Curves travels right over to NURBS Surfaces. And why is that? Well, a NURBS surface is really nothing more than an infinite, you can look at it that way, infinite number of NURBS curves that basically tie together, creating what appears to be a solid surface. And it is indeed a solid surface. That's just an interesting way of looking at it. But another way is you could say you've got one curve that travels the length of another curve, and that, of course, results in a surface area. Now, since we have two different directions, as you saw with a NURBS curve, you only had U. Now, with a NURBS surface, we have U and V, so two different directions. Now, let's start out, just like we did with NURBS curves, and talk about how do we create surfaces? Well, there's two different ways to go about doing it. Number one, a way that you've been using throughout this course is to use NURBS primitives. And we've already seen if we come up here to our main menu bar and go to Create and come down to NURBS primitives, we've got a bunch of different things that we can start with. And these can, from time to time, make great starting points for a model. Create a sphere, start manipulating the CVs, one thing leads to another, and boom, you have a model. Now, one of the more popular methods for creating complex NURBS surfaces, or models if you will, is through the creation of curve networks. And it's also referred to as curve cages. There's all sorts of ways it's referred to as. But generally, we'll just call it a network of curves or a curve network. So how do we do this? Well, let's go ahead and delete out that surface right there. I'm going to come up here to Create, and we've already seen that there's several different ways to go about creating a NURBS curve. Let's grab a CV curve real quick. And I'm just going to make, let's see, I don't know, something like that. Let's reactivate the curve real quick, and we'll go ahead and throw down some more CVs. Maybe something like that. So we've got two different curves. Heck, I'll go ahead, let's hit Y. I'll throw in one more as well. So something like this. So we are generating a network of NURBS curves that we're going to use to turn into a surface. Now we can, of course, come in here and start modeling by coming up to our component type and selecting CVs and manipulating them like such. Or I can just come in here and start right-clicking as well and selecting which things I would like to manipulate. So perhaps move that down, grab these two, move them up. As far what type of model am I creating? Who knows? It's just something. Maybe like that, and pull that forward and push that down. Wait, let's grab this guy. Push him down. I don't know. Something like that. Now, I can take these curves and turn them into a NURBS surface by using a series of tools that are available inside of Maya. And in the next few lessons that are coming up, we're going to take a look at the different tools that are available, at least a lot of them. So let's grab. So I'll grab the three curves. I'll come up here to Surfaces, and I know we've not yet got into this in depth, but let's just use it, Loft. So we have now created a surface from our curves. Now it's like some type of, I don't know what the heck it is. I'll hit 3 to up its resolution so it's smoother. Same thing we did when we were working with our curves. And I'll go ahead and hit 5 so that we can see a shaded view of it. Let's go up here to Show, turn off our grid, and move this up. Now we do have construction history in place, so I can come back in here, right-click on one of my curves, go to CVs, and continue tweaking the way this looks, and you'll see I get feedback on the surface. A very, very powerful way of modeling. So, two different ways we can go about creating NURBS surfaces, through primitives or through the creation of a surface from NURBS curves. Okay, now, what I want to do is jump over into the anatomy of a surface. What are the different components that are available? Let's go up here to File, do a new scene real quick, and we'll turn on our grid, just so we have a point of reference, and create a NURBS surface. So we've got a simple plane. Let's go ahead and move them up a little bit, scale them up a little bit, and let's go down to its input node and add just a little bit of additional detail, maybe something like that. Now, what components do we have available? Well, we know for a fact that we've got CVs because we've been using CVs over the last few lessons, actually project number 1 and at several different points. And we manipulated these CVs around to get, results we were looking for, like the curtains, etc. So let's jump over here into components. And you know what? I'm going to go ahead and turn off my grid. Make it a little bit easier to see what's going on. Now, with the NURBS curve, you'll remember that the very first CV was an open box representing the starting location of the curve. Guess what? It's the exact same thing when dealing with a surface. So we've got an open box here, and this indicates the origin of our NURBS surface. And in a minute, I'm going to show you a display option that's available to quickly show you where a surface begins and which direction is U and V. And that brings us to the next thing. What direction is U and V? Well, we get an indicator of this in our components through our CVs, just like we did with the NURBS curve. If you'll remember, with the NURBS curve, a U indicated the direction, the U direction of the curve. And it really wasn't a big deal with the NURBS curve because, well, it's nothing more than a curvy line, and we know where it starts, so that must be the direction of U. But it becomes a lot more important when working with a NURBS surface for the simple fact we have two different directions, a U direction and a V direction. So here we have an indicator, that's a U, telling us that this is our U direction. Over here we have a V. So this CV is represented through a simple V icon indicating that this direction is V. And then all of the other CVs are nothing more than little dots that you can grab, and we can get the move tool, we can move them around, and hey, we're modeling. You get the idea, okay? Now, before we continue jumping through all of the different components available on the surface, since we just talked about the U direction, the V direction, and the origin of the surface, let's jump back for just a minute into object mode, and let me show you another way that you can display that without switching over into a component mode. And this is very handy when you're working with, let's say, some sort of heavy patched model head or car or something like that. So I can simply select the surface, come up to display, and then come down to NURBS components, and a NURBS component that is available to us is the surface origins. And all this is a graphical icon that represents the direction V is running in, U is running in, and the surface normal. So V is always green, U is always red, so it's RGB, right? So you always call it UV direction or UV coordinates. So R is first in RGB, so that means that's U. G, greens, that's the second one. There's your V. And then finally blue, it's the surface direction. Just like we saw with polygons, they have a surface normal. NURBS have surface normals as well. This is the front side of the NURBS surface. That's as simple as that. Now let's go ahead and turn that icon off, because you'll notice as I deselect my surface, it is still visible. All I need to do is select the surface, come up here to display, come back down to NURBS components, and turn off surface origin. So it's a toggle. You can just quickly add that to your shelf if you'd like, if you need to find, or if you find yourself needing it a lot. Okay, so jumping back over into components. Now, we've seen CVs. Well, what about edit points or knots? They were available to us when we were working with curves. Well, we can see them here when dealing with surfaces. Let's just right-click, go over here to NURBS edit points. Now, all the little X's, basically everywhere that our isoparms, that's these lines right here, tie into one another. Okay, and we can kind of look at that as like a series of curves, if you will. Well, that's cool. So we do indeed have edit points or knots. Let's grab the move tool. Wait a minute, we do have the move tool. That's right. You cannot manipulate the location of an edit point directly. You need to go in and move the CVs. That's just how it works with NURBS surfaces. With NURBS curves, you can go in there, grab edit points, move them around all day long. You cannot do that when working with the NURBS surface. Okay. Now remember, we had spans represented with NURBS curves as the segment that was connected between two edit points. Well, let's go ahead and open up our attribute editor, make sure that we have this guy here selected. Take a look at this. We have spans on a NURBS surface just like we did on a NURBS curve, except instead of just one number for spans, we now have two different fields. We have two different numbers. That's right, it's representing both a U direction and a V direction. And we can see that in this particular case, our spans U and V are 3 and 3. Remember how we had the edit points? As a matter of fact, let's go ahead and jump back into that real quick. I'm going to come up here to my attribute editor, turn off auto load selected attributes so this does not refresh with anything else. So you can see when I deselect it, it stays available. Let's switch over into components. There's our edit points. 1, 2, 3, 4. And between the first two, there's a span. The second two, there's a span. And these two, there's a span. It's as simple as that. Now, Just remember, you can't move these knots around, or edit points. Remember, I can use those words interchangeably, and I will. Okay, you can also see, this is a very interesting thing to point out real quick, is the degree. We have 2 different degrees going on here. We have a 3-degree cubit going in the U direction and a 3-degree cubit going in the V direction. Yes, you can have a situation where it's a 3 and 1 or something like that. I don't know if right offhand we can. Let's just try perhaps a cylinder. No, we're not seeing it right here, but as a good example, this will work. Think about this. With a cylinder, couldn't we get away with our one direction, so running up and down? As a matter of fact, we could come back up to display, come down to NURBS components, and turn on surface origins again. So in the U direction, couldn't this be represented as a degree of 1? Because isn't it nothing more than a straight line? And remember, 1 degree curves were just that, a straight line. And then our V direction, which you can see down here, it's bright green. This right here could be represented through a 3-degree cubic curve, so that we have the round curvature needed to make that part of the cylinder. And you combine these 2 together, and you get, of course, the final result. Now, in this particular case, they're representing it with 3 and 3. Wait a minute. Hang on. Let's do that. We're still seeing it as 3 and 3, but remember, you turn this off up here. Be careful, because it's not going to reload when you click on it. And my job right now is to try to throw out as much information as I can quickly. But it's still the same thing. It's still 3 and 3. But we could have it where it's set to 1 and 3 if we wanted to construct something like this ourselves. And it's absolutely no problem whatsoever to Maya. You can also see here our spans U and V. This really makes sense. Our spans in the U direction, which is running this way, is just 1. And it is. I mean, if we had another line running around the center right here, all the way around the diameter of our cylinder, then we'd have 2 spans, a segment down here and a segment up there. Now, of course, going around it like such, we have 8 different spans. 1, 2, 3, 4, 5, 6, 7, 8, as seen there. Okay, so let's go ahead and get rid of that. I just wanted to show you that you do indeed have U and V spans, just like you saw with the NURBS curve. You have that available with surfaces as well. You just have 2, 1 for U and 1 for V. And the same applies for our degree as well, and they can be different. So let's go ahead and close that out, close that, and let's come back over here. Okay, so back to the anatomy of the surface. Well, technically all of this stuff is the anatomy of it. It's just some of it is a little more technical than other. Let's go ahead and jump back over into components again. Now, we know that our edit points are not really helpful to us here. They just help show us where our isoparms are intersecting with one another so that we can quickly count out our spans. Now, what I want to do next is show you an isoparm. Our isoparms are these lines that are running back and forth along the surface here. Except when you activate isoparms, you get an isoparm marker so that you can basically mark any place along a surface. Let's go up here to this particular pick mask. If I right-click, you'll see NURBS isoparms. Let's go ahead and activate it. Now you'll see that I can come in here and I can click on these bluish-colored lines, and they turn yellow. But I can do something else that's quite cool. I can click and drag. Look at that. Now, what does this give us? This gives us, it's an isoparm. I like to refer to it as an isoparm marker, allowing us to denote a very precise location on this NURBS surface where we can tell Maya tools to perform operations. Remember, we had the curve point back over on NURBS curves where I was able to mark out a specific location on my curve and say, chop it right there. The same thing works here. Now, I do have a surface point, just like curves had curve points, but the thing about a surface point is they indicate both the U and the V direction. And what if you only wanted to work in one particular direction? Not a problem. All I need to do is grab an isoparm, move the isoparm wherever I want. I can now come up here to Edit NURBS, jump down to, in this case, I'm going to do Detach Surfaces. I'm going to keep my example the same as what I gave you with the NURBS curves. Bink. Look at that. Did it detach? Let's go back over into object mode. 1, 2. I have 2 different surfaces now as the result of doing that detach, and I was able to use that isoparm marker as a way to tell the tool exactly where I wanted the detach to occur. Let's go ahead and undo a couple times so that we put all this back together. There we go. So we're back to just the marker as seen here. Now, I can insert my own isoparms to give myself more detail if need be. Let's say I wanted to make some sort of really sharp dip right here in the center. I could simply move one isoparm over, hold the Shift key down, and continue holding it while I drag out another isoparm and yet another isoparm. So there we go. Now I have 3. Now these at the moment are adding no additional detail to the surface. But watch this. I can come up here to Edit NURBS and then come down to Insert Isoparms. Maya's going to take a look at my isoparm markers that I have right now, bink, and add the isoparms right there. Now I have additional detail. If I switch back over to CVs real quick, woo, look at all the extra CVs I get. Now, if I want to grab all the CVs in the center and move them down, of course, I could do a very careful marquee select. Actually, if we just line it up like such, not even a very careful one, like that. Let's turn off our isoparms because we don't need those. There we go. And then, of course, I can move this, and there's that sharp dip I was just talking about. And this brings us up to the next component that would make doing this a lot easier, and that's holes. Remember, when working with NURBS curves, we saw that a hole was a straight line that passed through every single CV. And it wasn't really super helpful when working with curves because when you select a hole, you're selecting all of the continuous CVs on that row. Well, when you're dealing with surfaces, this becomes a very helpful thing. Watch this. I'm going to activate holes. Bink. Now I get this network of orange lines that's crossing through all of my CVs, and I can use these to come in here and quickly grab entire rows of CVs. Very handy. Now I can just grab that center one, move it down like such, and then if I wanted to, without even having to look for a specific angle, I can grab this outer one, scale tool, scale them in, just so that we can make that lip nice and tight like such. Look at that. Very handy. Now, you may be thinking right now that, well, holes look kind of cool, but come on. I mean, you can just line it up just right and do that marquee selection, like such, and think I have everything. True. When you're working with things that are not chaotic, what if you were modeling a very complex character's head that had a bunch of deep wrinkles in it that you had to actually model in, and now it becomes difficult to see which way your CVs are flowing? Grabbing a hole makes it a lot easier. So, we've looked at CVs. We saw that we still have knots, but they can't be moved. We've looked at isoparms and how they act as markers, allowing us to tell specific tools to do actions on the surface in that location. We've looked at holes, and we've seen how they are a bit more useful when dealing with surfaces than with curves. We do have one more thing, and that is to go ahead and turn these guys off. And let's come back over here. We'll right-click on this guy, and we can come down to the NURBS surface points. And with NURBS surface points, I can click and drag out, and we get a point, just like we did with NURBS curves. But take a look at the title bar up at the top. NURBS plane 1.uv. UV. 2 pieces of information. The first number is the U coordinate. The second number is the V coordinate. Very nice. And we can use this, again, for marking specific locations, for grabbing tools and doing specific operations at a marked location, etc. Most of the time, you'll find me just using isoparm markers because seeing how you can drag multiple ones out, it's very handy. You can place one wherever you want, and you're only working in a given direction, and that's always really nice. Sometimes you don't want to work in both directions at the same time. So that's pretty much going to wrap it up for an introduction to NURBS surfaces. You know how they're created, through primitives or through network curves, and then using surface tools available in Maya to generate the surface. And we've taken a quick look at the components and a way to tell where the surface origins are by using that particular feature inside of Maya. So with that, that's going to more or less wrap this video up. In the next video, we'll start talking a little bit about parameterization, what it is, and we'll be jumping back between curves and surfaces as I just get you sort of familiar with it. And I say that because, after all, the Maya Fundamentals course is not a modeling course. The idea of this course is just to get you introduced to enough of the technology and techniques available so that you can start using the tools and generate some simple models. And then after parameterization, we're going to be moving into all of the different tools available, or at least a lot of them, and then we'll start generating our models used for the abduction, which is going to be the spaceship and the alien and all sorts of cool things. So with that, that's going to wrap up this video. Thanks a lot.